Assalamu alaikum everyone, welcome back to Learn ASAP. So today I'm going to provide you demonstration of the numericals that came in the prelims paper. So we'll start with question number 2 and part 1, which is prove that these equations are dimensionally correct or not. Now the first equation is f is equals to pq upon p plus q. It is related to the thin lengths formula. Now first of all, what the first step of proving any dimensionally correct equation. Now if I take the LHS, that is frequency, F stands for frequency, I know that now whenever you take any unit, you have to find out what exactly is the unit of that quantity. Now frequency, the unit of frequency by which we denote it is centimeter. And centimeter, the dimension of centimeter is always capital L. So this is our LHS left hand side dimension written down. Now we're going to write taking RHS dimension. Now P, we know P stands for object and Q stands for image distance. Now distance is always measured in centimeter or meter. Now here we took F is to centimeters, so we're also going to take them into centimeter. So we're going to write PQ is equals to P plus Q. P is also centimeter and Q, that is image distance, is also centimeter, divided by P, which is again centimeter, plus centimeter. You can either solve it with meter or you can either solve it with centimeter. Now centimeter into centimeter is centimeter square because it is multiplication. But centimeter into centimeter plus, when you add it with, so it's always 2 centimeter because it's addition. These are the simple rules of mathematics. Now we know that centimeter to centimeter, these are 2, so we can cancel 1. Therefore, this is cancelled and we are left with centimeter upon 2. Now, you know in dimension we neglect any number that we get, so we're going to neglect 2 and hence our final result is centimeter. Therefore, it is proved that this equation is dimensionally correct because here we also get centimeter into L and here we also get centimeter to L. Hence, we can write that LHS is equals to RHS because both time we got L into L. That is L is equals to L. That's going to be our final answers. Now we're going to move towards the second dimension, second equation we have got. Now this equation may confuse some people because as long as we've heard about the frequency is always denoted by F. But if you look into your book, you will find that they also denote frequency with this symbol, which is read as nu. Now this symbol here, this symbol is used to denote the frequency. This is the wave velocity formula, which most of us know as V is equals to F lambda, that is velocity frequency into lambda. But if you denote F with V, then this one becomes F. Now for the to recognize the symbols, I have written velocity as this symbol like here too. Now what they have done is that velocity into lambda gives us V. Remember this simple V stands for the frequency here. Okay, so we're going to apply the same technique that we apply in any dimensionally correct equation that we're going to take in LHS. Now we know that this V stands for frequency basically, and frequency, the unit of frequency is vibrations per second. Now vibrations is basically not a unit or a quantity, so we can neglect it, but second is time, so the dimensions will be 1 upon t, or in short t negative 1. Now we're going to take we're going to take RHS, right hand side of the equation. We know that this is velocity, this is frequency, this is wavelength. So we're going to take the velocity upon wavelength. You know the velocity is always stands for meters per second, whereas our wavelength is always denoted by meter. Now meter and meter cancel each other, so in short I got 1 upon second, which in other words is 1 upon t, or dimensionally correct institute can be written as t negative 1. Hence it is proved that t on the left hand side we have t negative 1, on the right hand side we have got t negative 1. This equation is dimensionally correct. So in the end we're going to write that LHS is equals to RHS, that means left hand side is equals to the right hand side. This brings us to the end of the question number 2 part 1.